Hello everyone, we are Team KFC consisting of 4 members, Brendan Dillon, HAFIY HAKIMI, Mohamad Haziq Zikry and me myself JEEVAN with our presentation on PSDA Project 2. My name is JEEVAN and today I'm going to be talking about hypothesis testing for one sample. The purpose of hypothesis testing is to test whether null hypothesis can be rejected or approved. This test will investigate whether the average death event among the first 100 respondents is 50% and above with population variance unknown. Hence, the 50% death event as the median value of the data is 50 deaths, which is 95% significance level. So here we can see the first hypothesis statement, H null is mu equals to 0.5, whereas the second one is mu more than 0.5. The formula used for this test statistic is ZAK. ZAK equals to mean minus mu over standard deviation over square root of sample. The test statistic value calculated for ZAK is 3.33, whereas the critical region for ZAK in this two-tailed hypothesis testing question is 1.960. The p-value that we got here is 0.000868. So by referring to this graph over here, we can conclude that the test statistics 3.33 falls within the critical region, since the p-value 0.000868 is lesser than 0.05 and test statistics 3.33 is larger than critical value 1.96, therefore rejecting H null. And there is sufficient evidence to conclude the average death event among the first 100 respondents is 50% and higher. That's all. Thank you.
Moving on to the next hypothesis test, which is correlation. Correlation is used to test the strength of linear relationship between the respondent's age and also the level of serum creatinine in their blood. So our hypothesis statement is whereby the null hypothesis is there is no linear correlation exists between those two variables. Otherwise, there will be linear correlation exists if p is not equal to 0. So our Pearson's product Mohan correlation coefficient R is 0.1894759, and we use Pearson because both variables of age and serum creatinine are ratio. From there, we can conclude that the strength of linear relationship is weak and also positive because from the scatter plot, we can see that the line of the graph increases gradually. And since we know it's a two-tailed test, we already set the value for the significant level, which is alpha equals to 0.05. Degree of freedom, we obtain 97. From 99 is we only pick the first 99 samples from our data set. So 99 minus 2, 97. And we obtain the critical value t from the t table, which is 0.1984723. And the value of t we calculate from the equation. So we obtain the value of 1.9103. So since the p-value is equal to 0.59018, which is greater than our significant value, and also our t-value from the equation is lower than the critical value from the t-table, so we can say that we failed to reject the null hypothesis, which means there is no linear correlation exists between the age and also the serum creatinine. So I think that's all for the correlation. Moving on to the next hypothesis test.
Okay, so I'm Haziq, and the next test that we conducted is the chi-square test for independence. So this test is used to check if there's a relationship between two qualitative variables, and those two variables that we use is that whether the patient has diabetes and the sex or gender of the patient. So our hypothesis statement is that H null is diabetes is independent of sex, and H1 is diabetes is not independent of sex. So the formula used for the test statistic is chi-square equals to the summation of the observed count minus expected count squared over the expected count. You can see our test statistic value that we got is 2.4649 with a degree of freedom of 1, and the p-value is 0.1164. So the critical region with a significant value of 0.05 is 3.841459. So we can conclude that since the p-value is more than 0.05 and our chi-square value 2.4649 is less than the critical region, which is 3.841459. Therefore, our H null is failed to be rejected. Thus, there is sufficient evidence to conclude that the diabetic status of the patient has no relationship or is independent of the sex of the patient. So we'll continue with the next test, which is ANOVA. That's all from me.
Hi, I'm HAFIY. Now I'm going to present the ANOVA test for this project. ANOVA test is used to test the mean of the level of creatine phosphate CPK enzyme in blood between age groups. In this test, I only used 30 samples which are divided into 3 age groups. The first age group is 40 to 59 years old. The second age group is 60 to 79 years old, and then the third age group is 80 to 99 years old. So all the age groups consist of only 10 samples. So the hypothesis statement is the null hypothesis is all the means of the 3 age groups are equal, and the alternative hypothesis is at least one mean is different. Okay, as you can see on the right side is the final results of the ANOVA test using RStudio. So referring to the results given in RStudio, the numerator of the degree of freedom is 2, and then the denominator of degree of freedom is 27. By using significance level 0.05, the critical value can be calculated and equals to 3.354. And then as also based on the results in RStudio, the test statistic calculated is f value equals to 1.342, and then the p-value from the results is 0.278. So as for conclusion of this test, since p-value is 0.278 is greater than 0.05 and f-value statistics 1.342 is less than f critical value, which is 3.354, we fail to reject the null hypothesis. There is sufficient evidence to claim that the different age groups have the same mean for the level of CPK enzyme in the blood. So that's all for ANOVA test.
So for our conclusion, we can say that the average death of those who diagnosed with heart failure increases from time to time because of the rejection of the null hypothesis. Because as you can see from our first hypothesis test that we conducted, which is the hypothesis testing of one sample, we can see that the average death is more than the 50%. And also from correlation tests, we can say that the level of serum creatinine in each respondent's blood differs from one another, and it can increase or decrease at any age. And also from the chi-square test, we can say that the gender indicator is independent to those who have diabetes and also heart failure. And last but not least is from our ANOVA test, we can say that the average mean of the level of creatinine phosphate enzyme is the same among 3 different age groups, which means that there is no difference and the rate of the enzymes is the same for the age groups. In short, we learned a lot from this project. We learned how to apply the hypothesis testing on real life data set and see how important it is to apply this hypothesis testing to obtain a very crucial statistics value, because it helps with because it ensures the smooth of the data flow and also prevent any errors occurring during the calculation. So I think that's all from our group. Thank you for watching and have a great day.